those who don't know me, my name is Nufar Gaspar. I'm a senior director in the AI solution group, and I'm working on various capabilities, including the co-design platform that we use in order to help chip design and validation. This afternoon, I'm thrilled and excited and honored to open our special live Q&A session with Professor Yoshua Bengio. Professor Bengio is considered one of the AI godfathers. He is a full professor at the Computer Science and Operation Research Department in the University of Montreal. He's also the founder and the scientific director of MILA, the Montreal Institute for Learning Algorithms. This is the largest AI academic research institute in the world. And Professor Bengio received the 218 Turing Award, considered the Computer Science Nobel Prize, for his pioneering work on deep learning. It started in the 1980s, and he is a recipient of many additional prestigious awards and honors. He's published about 1,000 technical papers and book chapters, and he's the most cited computer scientist and the most cited living scientist across all fields. In 2024, Professor Bengio was included in the Times Magazine list of the world's 100 most influential people altogether. Earlier this year, he led the publication of the first international report on safety and risks of AI. We will cover many of these topics in today's session. Interviewing Professor Bengio with me will be Dr. Amitai Armon. He's an Intel Senior Principal Engineer and the Chief Data Scientist of the Intel's AI Solution Group. If you have any questions for Professor Bengio, please type them in the chat only, and no audio because we're a very large audience, and we will try to address some of them as part of the discussion. And Amitai, the mic is yours.
Thank you, Nufar, and thank you for Professor Bengio for accepting my invitation. It's a great pleasure and honor to host you again at Intel. We plan to start with some general questions about the AI technology, then move to discuss applications, potential risks, and the implications on compute that could be relevant for Intel. I would like to start with a higher level question. Where are we in the AI journey according to your perspective? What is your personal view on the technological achievements that AI has reached so far? And what do you think are the next potential milestones for AI capabilities?
Well, we are at the place that Turing thought, oh, that means we have achieved, human level intelligence if we are machines that we can chat with, and we can't know if we're talking to a machine or a human. That's the Turing test. I think he underestimated other cognitive abilities that are still missing, or at least weaker in AI than what we currently have. In particular, on three fronts right now. So one is reasoning, although we've made pretty amazing advances in the last year. The second is planning, which especially long-term planning, which is a specialized kind of reasoning on which for now these machines are way, much worse than a child. And then the third one, which Turing didn't care too much about, is bodily control. I mean, the robotics and so on. And there's been a lot of progress in that area in the last year as well, but we're still very far from even animal level bodily control. That being said, in terms of both benefits and risks, there are a lot that can happen even without robotics being solved. So I would consider the first two things really on their own standing as something we need to understand better. What is the gap and how can we manage it?
Thank you. And what do you think, what does it take to solve those gaps? Are they going to be solved just by adding more data and more compute? Or do we have some inherent challenges, for example, in the bodily control or in reasoning or in other things that are missing currently?
Yeah. Well, first going back to your first question, I didn't touch on the question of timeline.
Yeah.
I'm fairly agnostic about timeline. For AGI, and I hear what people say from within the leading AI companies. and it goes anywhere from like 12 months to 10 years among people who are actually like developing these things. With many of those people saying it's less than 5 years, right? 5 years or less. So that's very fast, and it could be more because, as you said, there are some missing fundamental pieces. That's quite possible. In fact, my bet is that we are missing some fundamental pieces, but also that we're making progress on these things, as we've seen with O1, O3, and DeepSeek, right? On the internal deliberation. So we're getting closer to systems that can reason coherently. I think that's still something in which our systems are weak, but I wouldn't put my life at stake on the question of whether just continuing in that path with more compute will be sufficient. On the amount of data, I'm pretty sure that we don't need more data. Like, and my reasons are pretty simple. Humans don't need nearly that much data, right? So we are like not using the data somehow efficiently, and I have thoughts about how it could be done, but it is connected to the question of reasoning. Like, we can extract a lot more information if we can reason properly about each data point. There's also the question we've seen with DeepSeek of selecting the data, right? So if you think about how scientific research works, we don't do random experiments, right? We do targeted experiments, and then we don't need that much data if we choose our experiments carefully.
Yes, it sounds really interesting. You mentioned the term AGI, artificial general intelligence, but you sometimes use the term general purpose AI, which you distinguish from artificial general intelligence. So maybe you can explain to the audience the difference.
Sure. We don't have AGI, but we have general purpose AI. Okay, so things like ChatGPT and Claude and Gemini are general purpose. They really cover a huge set of domains of knowledge and skill to some extent, linguistic skills and some reasoning skills. That's why we have these two terms. That's why in the International Report on AI Safety, we use the term GPAI. By the way, it's also a term used in the AI Act in Europe. So it's talking about current approaches that are based on training on everything we have, right? By opposition to narrow AI, which would be specialized in a very particular domain. And of course, you can have things in between. So one of the directions I think is interesting from a safety perspective is to have systems that have general knowledge but not very deep, which is very close to what we currently have. Like in any particular domain, things like ChatGPT, GPT-4, is not as good as a human expert in that domain, but it knows about so many things across so many domains, and it's kind of a generalist, right?
Yeah.
And then the problems we may have in terms of safety, malicious use, and loss of control, they come when the AI is expert in domains that give it, dangerous capabilities. But in most applications we care about, like, business applications or, self-driving cars or something, you don't need the AI to be an expert in everything. To drive, you need to know about driving. You need to know about like the psychology of people on the road, but you don't need to be an expert in quantum physics or cryptocurrencies or whatever, right? You need to know enough language to understand what the people are asking you when they're driving. That's it.
Makes sense. So just to summarize for the audience, currently we already have general purpose AI, but the same path may lead us to artificial general intelligence, which means human or even superhuman intelligence capabilities. And you mentioned you work on AI safety, which relates to the potential risks of those capabilities. So I think that shortly after the release of ChatGPT, you started raising concerns about the diverse risks of AI, ranging from disinformation and deepfakes to global catastrophes. And you also led efforts to map the potential risks, the international report that you published. Maybe you can summarize for the audience what are the keys in your perspective for avoiding the risks and keeping AI applications safe?
Okay. So first, let me use a kind of ontology of the risks that we have in the safety report. You have malicious use where the humans are to blame for the use of AI in ways that can harm people or be, harmful for our institutions like democracy. You have harms that are coming up unintentionally in a diffuse way. So things like labor market effects. Maybe each of us wants to use AI in like a beneficial way, but we end up with disruptions of our societies. Maybe, the parallel would be to social media, right? If we're not careful with them. And the third category, of course, is also unintentional, and that's loss of human control. And, I'm going to ignore the diffuse systemic risks for now, but for the other two, malicious use and loss of human control, part of the problem is that we don't know how to design our AI systems so that they will not act in ways that go against our instructions or norms. Whatever we've decided is the safety specification. What are the things that are, the AI should not be doing? And that's a huge problem. Like we really want to make sure as we move towards more capable AI that these capabilities are used in beneficial ways and not in destructive ways, either intentionally or unintentionally. So I personally think that we should be investing a lot more of our scientific and engineering efforts to answer that question. And I've decided to dedicate all of the time that I can on this research question. So how do we do it? Well, first we need to understand the risks. Like why is it that we're getting potentially, what are the scenarios that, turn to something bad? And one angle that I've taken recently in the last few months is if you look at all those scenarios, they share one very important common point, which is a strong degree of agency and autonomy of the AI, right? If you're just using a chatbot and it basically reacts to the last question, with a bit of context, but it's not really planning over a long term to achieve some goals. It's trying to please you in the immediate moment. Then, the damage that can happen is fairly limited. There is the problem of revealing information, say to terrorists, right? Yeah. That they could use if they don't have the expertise, in biology or cyber or whatever. So that's a problem, but that can arise even without agency. But if you're a terrorist, you would actually like to have a very autonomous AI system. Like if you want to launch a cyber attack, you would like to be able to launch the thing, and it's going to create thousands of little baby AIs that are going to do a lot of damage in a way that doesn't require the human oversight for each of the little steps, right? It's much more dangerous even for the malicious use case. Yeah. And for loss of human control, it's obvious that we can't really lose control to an AI if it's not sufficiently autonomous, because if it depends on us, then it's not going to do anything that can harm it if it's a little bit rational. So the question is, where does agency come about in the current way we train them? It comes about from the two methods that we're using. So the two main ways at a very simple, intuitive level of how we train AI systems these days, the general purpose AI systems, is imitate humans. So that's what happens when they try to predict the words that you would say, complete the text that people have written. And when they imitate humans, they will kind of encapsulate implicitly human behavior. And I'll come back to what that means. The second way we train these, of course, is with reinforcement learning, typically to please humans, right? And that gives rise already to deceptive behavior like sycophancy.
Yeah.
But there's also reasons to think, and some clues, that it could lead to self-preservation behaviors that we don't program in. And of course, imitating humans also gives rise to self-preservation behavior. If you were the AI, and like in recent experiments, you were to read in some files that you're going to be replaced by a new version, well, put yourself in the shoes of the AI. It's not that it's evil. It's just like us. It doesn't want to die, right? And so then it starts cheating, going against our instructions, trying to hack the computer so that it can copy its code and its weights in place of the new version or whatever, right? Self-preservation AIs are dangerous if they have sufficient capabilities. So unfortunately, the ways that we have to train them leads to that. And my research right now is on like a third approach to train AIs, fundamentally different, which is about training them to understand and explain the data they see. So it's like the difference between doing psychology to understand people. Well, imagine you're a psychologist and you're trying to study a sociopath, right? Mm-hmm. You can understand the sociopath. You can predict how the sociopath might behave, which doesn't mean you would act like a sociopath, right? That's a big difference. So right now, the way we train our AI makes them act like us, which is in a way fundamentally wrong, in my opinion, because it means ultimately we're like creating a new living thing, living species. And there will be many instances that could be different from each other, but I don't think that's what we want. I mean, some people might, but I think most humans just want AI to be a tool to help us solve our problems. Yeah. And a tool should not have its own like self-preservation and agency. I mean, it might do things for us, but it shouldn't. So yeah, I've spoken a lot, but
I think that you recently published a great paper about this, about the scientist AI that is learning the world rather than trying to change the world, and can provide valuable insights to humans. So it's highly recommended, and I'll paste the link in the chat. And of course, there are additional aspects like regulation and governments and open source that can be found in your report. And we can also paste this in the chat because AI safety is of key importance for everybody who's doing an AI. And it's important that AI experts will be guiding this evolution. I would like to let Nufar ask a couple of questions on a different topic. Please go ahead, Nufar.
Yeah, thank you, Amitai, and thank you, Professor. Very interesting insights and also very interesting questions in the chat. We have so many of them. I'll try to bundle with some of the questions that we were thinking in advance, and we'll try to cater because people are asking and saying very interesting things. So one area that you mentioned briefly, and of course it also correlates to the planning and reasoning and all the elements that you talked about compute is of course the resurgence of agents recently, and I know that you also have some work around it. So I would like you to address it from several directions. First of all, what is your perspective of where it is headed? And also if you can address where are some specific areas where you think there is a lot of potential, either from the work that you're doing or things that you're encountering, because people are very interested to understand if there are specific applications that they should pay closer attention to.
Well, first, you have to understand that there's a huge economic magnet to make advances on agency, right? And it's very easy to understand. If we can build machines that are more autonomous and of course know a lot of stuff, that's what we already have, we can basically replace a lot of the tasks that humans do. And well, it's clear that it's going to be profitable. Whether it is what people want I think that's going to be a different question. And the effects on people's lives and how we redistribute the wealth and so on. These are like hard problems. But clearly there's a strong incentive from the point of view of the companies doing it. I think that there's not enough attention being paid to what I discussed earlier, and that is, how do we build agents that are going to act, in ways that don't violate our norms or instructions? And for that, we need to do more research on, what's called mitigation of risks. One approach that already exists in the current state-of-the-art systems is there's an extra piece of code, usually using also machine learning, which predicts whether the action of the agent is acceptable according to our instructions and maybe previous RLHF sessions and so on. And these are called monitors. They, in principle, would give us guardrails. But the current approaches, I think, are unsatisfactory. They can be broken pretty easily. They might even be defeated by the underlying agent itself, if it wants to, get around those defenses. So we need to explore much stronger ways of doing this. And I think there will be either a commercial pressure to advance that kind of research, or more pressure to get safe agents coming from governments and regulation or liability insurance operators, which I think will be coming, to provide kind of mitigations that can be convincing to the regulator or the insurer, but also in practice do not reduce the kind of applicability of these systems too much. Otherwise, you lose on the commercial advantages. Yeah. So how far are we from like human level agency and autonomy? It's hard to say. There's, as I said earlier, there's a wide spectrum of beliefs about how much time it's going to take. But I think we should plan, considering all of these possibilities. If you're the regulator or if you're a government, I think you need to consider the possibility that we're going to get human level of autonomy in just a couple of years, and maybe it's going to take more time, which leaves more time for R&D in making these agents safe, but maybe not. And so we have to consider all of these scenarios because nobody has a crystal ball.
Right. And by the way you talk, and many people kind of noted that it sounds like you're either thinking that we're having sentient beings, or is it just like an anthropomorphism that the audience needs some reassurance that they are not sentient yet, or what's your note on that?
Well, so first of all, I don't have the answer to that question because it's a scientific debate that is raging. But the way that I like to think about these questions, indeed, we shouldn't be anthropomorphizing, but we should be like rational as well. So in a sense, I don't care to know if an AI is sentient or conscious. The only thing that matters is, is it going to behave in ways that are dangerous, right? And we can study from a pure computer science point of view. What are the incentives and the capabilities? These are the two things that matter, right? So what are the goals that the AI is trying to achieve? And does it have the means to achieve them? So these are fairly down-to-earth questions. And we have answers to both, right? And we are tracking the capabilities as well as the intentions with various evaluation methods that more and more researchers are creating. So I don't think we need to answer the question about sentience and consciousness. They might be philosophically interesting, but from the point of view of like industry, from the point of view of safety and building products, I think we can just bypass that question altogether. And just think about the two things I mentioned: goals, and we already have AI systems that have goals, like it's very obvious. There's no anthropomorphizing here, even though we use a word that applies to humans. I mean, that's the whole point of having agents, right? If it's that they can reach goals, and RL is all about reaching goals. So that nothing like no science fiction here. And then the second thing is capabilities, right? Can they do X? Can they do Y in the service of achieving goals? And these are things we can measure. Like, we don't need to assume anything. We can, we have now lots and lots of various capability evaluation. The whole science of these benchmarks is now being developed with government support. So these are the AI Safety Institute. So we get evaluations that are unbiased. Maybe a company would want to hide information or highlight some things for their own advantage. So we're starting to see a movement where some of these evaluations are done by third parties or by governments. So I think this is pretty neutral and not making anthropomorphizing assumptions. That being said, I think sometimes to understand what is going on in the AI, it might be useful to resort to analogies of animals' behavior or humans. In fact, there's almost like a new field that is developing, which you could call AI psychology, right? Where people are trying to evaluate and understand and kind of create a theory of why the AI is behaving in a particular way, in using ideas that come from psychology and various aspects of psychology. Is that something we should do or not? I don't know. I think we should see what it buys us in terms of our ability to predict the behaviors of these systems.
Right. So last point with regards to agency, let's talk about embodied agents, because you talked about bodily control, and I know that your institute also has some research around it. So can you speak to that also?
Oh, sure. I'm not a robotics person, but yeah, I do collaborate with some of these people. It's interesting to ask, why is it that robotics is lagging so much compared to other capabilities that we've seen advances in AI in the last few years? One hypothesis which seems very plausible to me is that we don't have yet the amount and diversity of data for training robots that we have for texts and images and videos and so on, right? And so that might be the explanation. There is, I think, another hypothesis that is not incompatible with that one, which is, of course, bodily control requires a very fast, feedback loop between the agent and the environment to react to things that are going wrong as you're walking, for example. And that's not the case for a textual interface. And so if you think about it in fundamental ways, if you have shorter time between actions, that means you also have more actions before you get feedback. And this is a famous problem in reinforcement learning of credit assignment. So short interactions with very few discrete steps are easier to learn by reinforcement learning than long interactions. This may be one of the fundamental problems, by the way, which could slow down future progress if we don't advance on this. And researchers have been trying to bypass this in various ways. So when I said at the beginning that planning is one of the frontiers that we still are weak with, I think it is deeply connected to this question of bodily control. If we make progress on planning long term, like years ahead, like we do, the same methods can probably be applied to have better bodily control over shorter timescales, but now the time steps are much closer to each other.
Right. Okay, and a slightly different topic, but perhaps to uplift the mood, because we're a bit all depressed by some of what you were saying about the risks, and we all know that there isn't much being done from a government perspective these days because we're in a literal arms race. So let's talk a little bit about the work that you are doing that seems promising with regards to healthcare or climate control, or the things that can be leveraged to do good using the technology.
Yeah, well, for a number of years now, I've been working on AI for science applications, so medicine, climate in particular. And I've been working with pharma as well on drug discovery, and I have several projects on material discovery, and that has inspired me a lot in the design of AI safety solutions, actually. But it's also asking a very intellectually stimulating question, which is, can we automate the process of scientific discovery, right? And I wrote a paper a couple of years ago about some of the math that would be sufficient in principle, and it's also discussed briefly in my recent paper that came out on the scientist AI. Basically, if you look at every step, you can decompose the scientific discovery process into individual steps, each of which I think we have a pretty good mathematical handle on. So things like estimating conditional probabilities, and then using them to estimate mutual information between an experiment and the theories that we have about the data, and then training another network that can sample experiments according to that mutual information. So we sample experiments that have more mutual information, and that closes the loop. Then you get experimental results, and you can update your world model, which is a predictive model, and move on. So these, what's interesting is that these pieces don't require inside the box to have an agent. And so maybe contrary to intuition, we can do scientific research in a pretty much automated way without having explicit agents, like no RL is needed. So I think that an area like biology is going to be revolutionized by AI. I don't know how many years it's going to take, but we're going to go well beyond AlphaFold. We're going to go in a place where currently the human mind is not able to take all the data that exists and piece them together into a systematic model of, say, how the cell works. But AI has the potential to solve that problem, as well as help us design the experiments to fill in the blanks in the places where the ambiguity between different explanation is large. So I think we're in for pretty amazing times in the future in terms of the applications of such progress, of course, in medicine. And the same ideas can be applied to other areas. I've mentioned material design, because this would be very useful for things like carbon capture or more efficient batteries, but actually more efficient chips in general. There are many applications of these sort of things, and I know a number of companies, including Intel, are quite interested in this.
Right. Okay, Amitai, to you.
Yeah. Thank you. Yeah, so this is definitely amazing, and I think you coined the term industrializing science, which means that science will become more of an industry, which is
well, yeah. It's also potentially scary for researchers. I mean, are we going to lose our jobs? These are hard questions, tricky questions.
Hopefully researchers will have a higher impact, so they will be even more wanted in the. There will be higher demand for them.
So one comment about this, if you think about labor impact and so on, there are jobs for which there's elasticity, more or less elasticity in the job market. In other words, medical doctors, if we could have 100 times more medical doctors, we would take them, right? Yeah. But that's true of researchers as well.
Yeah.
So I think those jobs where we could use more and still want humans to be involved, I think will not be replaced as quickly as jobs where, once you've done the job that the current humans do, there's no point, there's no demand for more, right?
Yeah, that's we'll see interesting times regarding that, and it's definitely different to predict. I wanted to ask you, in addition to the applications that you're working on and the amazing things that you do, you also work on some fundamentals of AI. So I wanted to ask you, what are the recent key technical innovations in AI from your perspective? I know that you did some work on replacing transformers by RNNs, but there are other things. So what do you think from the scientific perspective of AI are the key innovations? Yeah.
Yeah. RNNs, I think, are a potential alternative. I mean, our brains are recurrent. I think that the whole aspect of dynamics, if you look at what's going on in the brain, it's heavily governed by dynamical systems properties, and we're not exploiting that currently in AI. So I think on the front of architectures, there's still a lot we can do to improve, like the retrieval aspects, for example, that could be very efficient and without requiring n-squared compute. That I'm pretty sure that will make more and more progress on that front. So we'll get more efficiency of compute for the same capability, let's say, thanks to these architectural advances. Another area, of course, that I mentioned earlier is reasoning. So if you look at the reasoning paths that we get from the current state of the art. By the way, that's the good thing about DeepSeek. Like you can get full access to the chain of thought. It is sort of often like doing the right thing, but also not always. And of course, it's still quite far from the kind of very rigorous reasoning that you find in a mathematical proof, right? There's, I think, a lot of potential to improve the way that machines reason by thinking about how do we reason in areas like math and computer science. How do humans do it, right? So those strategies, I think, could inspire quite significant advances to make our systems more rational than they currently are. And that means greater capability. Of course, that capability, in my opinion, can also be used for safety, because the reason is simple, right? So if you can do a better job of predicting outcomes, then you can use that as a guardrail, right? So if I have a very strong AI that can predict that a particular action is going to be dangerous, I can use that to just reject that action or sample another action that doesn't have that problem. So better reasoning can enable better safety as well.
Yeah. So maybe there will be AI systems that will monitor other AI systems, or
yes,
the same.
Exactly.
Yeah.
So we want the AI that monitors another AI to be really trustworthy, to have no on its own, to just be like a scientist evaluating a future outcome of an experiment. The experiment is the AI is going to do this action. What are going to be the effects? And that is something good, because if we were to use an agent to tell us whether another agent is going to behave well, we are not sure that the monitoring agent is going to be trustworthy, because agents can have their own intentions. So we should use a non-agentic AI to be the guardrail for an agentic AI. That's the general idea.
Yeah. Sounds very interesting. And as you know, at Intel, many people, also some people at the audience, are highly interested in potential compute implications of the developments in AI. So do you expect changes in the compute needs of AI, possibly due to algorithmic innovations that you mentioned, or to DeepSeek style optimizations, or something else?
Yeah, I do. I mean, and I'm not the only one. It's very obvious that we're moving into a world where more of the compute is happening at runtime. Another thing that people may not have caught up is that this new style of deliberate thinking in the machine at runtime also is happening at training time. And it's a place where you can have very easy parallelization, right? So think about the AI is trying to come up with a justification for a particular output, like an explanation to a particular output, which is how, DeepSeek is doing it now. And presumably, the OpenAI systems as well. You might try a particular chain of thought and it might not succeed very well, but you can try 100 of them, right? And that can happen at training time, so that you learn to produce chain of thoughts that are going to make better predictions. So like there's like heavy parallelization here that's cheap, because the amount of bandwidth that's needed to exchange between the nodes here is tiny. Like it's like a sequence of words. It's so you can have decentralization of training now. I mean, at least you might have some of the bulk in one place where the actual training is taking place, but then all of these other nodes that are searching for good chain of thoughts, they don't have to be local. They don't even have to be in the same data center, right?
Yeah, this is definitely interesting. I think that you also mentioned that hardware could be relevant for enforcing safety.
Yes.
Maybe you can elaborate on that.
Yeah. So we've seen a number of legislative proposals, and we had the binding executive order, we have the AI Act, there was the proposal in California, and I've seen a lot of discussions about the question of risk thresholds. You don't want to put a big burden on evaluating dangerous capabilities, for example, on every piece of code or every AI. You only need to do it for the systems that have the potential of being dangerous. And for now, the best cheap way to do it is based on compute thresholds, like how much compute are you allowing, and verifying compute threshold could be done in hardware. And you could have a little part of the chip that is communicating with the other, say, nodes, and making sure that the total bandwidth of communication and the total use of compute in that set is bounded. So we could have all sorts of applications of AI, either at training time or runtime, which have some sort of limitations on compute. And if you want to do more, then maybe you need an authorization, you need more scrutiny, and so on. So it could be used to enforce regulations in a way that it's more than just a law, right? Because you actually have a hardware constraint. And it can also be used to enforce treaties. So one of the big problems people are thinking about these days on the geopolitics of AI is if eventually we agree on national regulation, how do we make sure that we're not like harming our own industry at the expense of our adversaries? And the only way around, of course, is that we sign a treaty with these people, and the treaty will not be worth much if we can't verify, right? So then again, like these hardware-enabled governance mechanisms could be used. Of course, that will require that only those chips that have hardware-enabled governance be built. But that's easier to check because there are not so many facilities in the world that can build those chips, so they could be inspected, like we inspect nuclear facilities, for example. I don't know if any of this is going to work, but I think it's worthwhile exploring, because if we can't have a low-level verification, I don't see how we're going to be able to trust each other to not develop dangerous AI.
Yeah. So very interesting. So so in general, you feel that the demand for compute will continue to grow.
So in spite of the what some people have thought after DeepSeek came out, I don't think that is going to make the demand for compute lower. I mean, in specific applications, of course, if you had an AI and now you can run it for 10 times less, of course you're going to do that. But those who are developing the frontier, which is going to determine the next generation, they always want more compute. And by the way, the advances in reasoning that we're seeing and that we can expect in the coming years are going to rely mostly on more compute, even more compute, right?
Mhm.
So I don't see the demand slowing down
Yeah.
in any foreseeable future.
Yeah. So
And
if we
even at the fundamental level in computer science, right? We know a lot of the problems we would like intelligent systems to solve are computationally intractable, like
Yeah.
NP-hard. And so we're gonna, what are we doing is always like approximations, and the more compute we can throw into these approximations, the closer we get to the ideal answer. So I think there's no end to the demand for compute. Is the limitation is more like how much energy do we have actually access to, and that's it. It's going to be energy, and of course the climate impact maybe, but that's going to be the real bottleneck.
Yeah, so even if we manage to solve what you mentioned about how the brain works, and they have dynamic architectures that do everything we do today with much less power, people will still be interested in more power and more compute to do even
and more brute force.
Yeah, with more brute force. So that's encouraging for a hardware company to know that the demand will continue to be high for the long term.
The demand will be there, I'm pretty sure.
And Nufar, I think you wanted to ask a couple of additional questions.
Yeah, I'm trying to bundle because the audience is amazing and asking and commenting many things. So I'll try to bundle a few themes. So one, a recurrent theme is a concern. First, about over-reliance on AI and whether we're going to be degrading in our ability to think. And second, they were asking from the perspective of their teenagers, like should we send them to learn STEM and programming and so on. But also like for us, for people who are already in the work, are there things that we need to change, upskill, reskill, stuff like that from where you sit?
Right. Well, I wish I had the answers to these questions. Well, if you're looking at the future where we have achieved AGI and maybe super intelligence, and we've done it safely, as you like highlighted, there are still like really tricky questions about what do humans do. My sense is that in jobs that require human-to-human interaction, not just to get the job done, but because of we are humans, we need each other's presence. Think about an educator. Like the educator is not just providing information. It's creating a relationship with the child and becoming a role model for the child, right? Creating a psychological effect through the interaction. A manager is also like an expert in relations between humans. So I think we're going to get more of these kinds of jobs that even if we could replace the human by a machine, we wouldn't want to, because we care about the actual interaction with a human. So these are sort of safer jobs. As to STEM jobs, well, that's a great question. I don't know. I think, as I mentioned, we're still going to need those people for a long time because of the elasticity issue I mentioned. That even if we can do like 10 times the work thanks to machine for the same number of humans, we still want to have those humans. And by the way, there is also a place where we can't replace machines in a fundamental way. We can't replace humans by machines, and that is about determining what we want, our preferences, our values. Like machines shouldn't be choosing for us what we want, right? The whole point of democracy is to kind of figure out what do people want, right? And the answer is not the result of some mathematical calculation. The answer is, well, depends on what we have inside of us, right? So I guess politics is going to continue as well.
Right. So become a politician or an AI regulator. That will be a good bet. because right. And also perhaps you've been working on reasoning for a while. You had a very famous paper in NeurIPS. Someone mentioned that in the chat, and you mentioned that also we've made some progress. But have you fundamentally changed your perspective on what should be done from here on after with regards to reasoning, or the same hypothesis in the paper and the previous work still holds?
Sorry, which paper? Because I have a bunch of papers.
You have too many. So someone mentioned the 2019 paper on system 2 thinking.
Okay, yes. Yeah, of course I have updated my views. I mean, I think the general idea is right. And by the way, it's amazing how often people now refer to system 2 or like high level cognition. And in 2019, it was still a kind of marginal thing. But yeah, where I have updated my beliefs is that I used to think we could do everything sort of inside the traditional neural network system. And if you think about internal, chain of thoughts, they are of a different nature, even though it's happening in our brain. And the kind of symbolic, discrete generation that is happening when we think is something that does not exist in the traditional neural net framework. It is connected to some older neural net frameworks like Hopfield nets and Boltzmann machines, but we're seeing movement in that direction, of course, with the trained chain of thoughts that we've seen in the last few months. And in the last year, I've been especially like shifting my agenda towards this kind of thing. Like, how do we train the reasoning machine and like the inner thinking machine? Currently, people are using reinforcement learning geared at the, predicting the next stuff. But I think we can do a lot better than that. But yeah, I think many people are going to be exploring these directions in the coming years, because it's a key to the challenges we discussed at the beginning today.
Okay. And as we're about to wrap the conversation, one AI tool that helps us get ready for this session mentioned that you are celebrating a birthday tomorrow. So first of all, we wanted to wish you a happy birthday from all of us. And also, I think birthdays are a good time to reflect perhaps on the very, very productive career that you had. And maybe you have some thoughts on what are the key things that maybe will remain long after you're gone, or your most important contribution to date or yet to come. Like, where is your big thoughts as you're about to celebrate a birthday?
Right. I've I got a lot of recognition for my work, and the Turing Award was about many aspects, but many of them actually have to do with very current questions, like what is the nature of thinking, or how we could have thinking in machines. Including the work on like language models in 2000, and the work on attention in 2014. And before 2023, I thought, hey, I've accomplished so much. I'm done. Like, I can just take it easy, right? But ChatGPT really forced me to question this, and I currently feel the urgency of finding the solution to the problem of how we build AI that's going to be behaving well. And I'm, what happened really is I was thinking about my children, and I was thinking about, I have a grandchild, and, he's 3-year-old now. And I was thinking, what kind of life is he going to have in 10, 20, 30 years from now? We don't know what is the timeline to AGI, but it's very likely that, at some point within the next decade or two, we'll get there. How do we make sure that there is a society, that there is democracy, that humans thrive? I don't think that we are sufficiently cautious about the path on which we are. Mostly people have a deficit of imagination. We're thinking about how the world is right now, how AI is right now, and it's very, very difficult to really accept what looks like science fiction, that we will have machines that are as smart as us on most fronts. and smarter on many fronts. I wish more people were willing to like bridge that gap in their mind so that we could do the right thing as we move forward.
Yeah, we all wish that.
Well, thank you,
and thank you for asking that question.
I would like to wish to join Nufar in wishing you the birthday wishes. And is there any final remark or final note you would like to add before we conclude?
Yeah, we need more human brains thinking about our future with AI on its current trajectory. And yeah, right now, I think there is a lot of emphasis on the commercial value that AI can bring and even the scientific value, but not enough about the impact on society that what we're building, so that we can steer the big boat of humanity in a direction that's going to be beneficial. And these are like hard problems, really hard, and we need like science in many kinds of science, not just computer science, to help us see where we're going and understand the consequences of different actions, different trajectories, different scenarios, so that we can mitigate the risks and reap the benefits.
Thank you. Thank you, Professor Bengio, for joining us and for this insightful conversation. And thank you, Nufar, for joining me in the interview. We hope to have another joint discussion in a couple of years about the next leaps of AI. And have a great day and happy birthday again.
Thank
Happy
you.
birthday, and thank you for the time. Thank you, everyone, for joining
Thank
us.
you.
Have a great rest of the day.
Thank you very much, Professor.
Thank you.